Hi, it's Mrs. Sneddon. Let's have a look at how we find the mean and standard deviation with some further examples. So here's example 1. So we're talking about the number of hours of sleep that a student gets each night is normally distributed and it's got a standard deviation of half an hour. So we don't know where the mean is, but let's just put that down. We know that it'll be in the middle, and underneath it I know my standard deviation is half an hour. So we want to find the mean if the probability that a student gets less than 7 hours. So less than 7 hours, so that probability there, and there's my 7, that probability is 0.15. Okay, so this is our X distribution. So what we want to do is we want to first of all find the equivalent Z distribution. So on our Z distribution, that has a mean of 0 and a standard deviation of 1, and we want to find the Z value down here where that area is going to be 0.17. So notice that the Z value is below the mean, so that means that I'm going to end up with a negative Z value. Okay, so what we want to do now is we are going to jump into our graphics calculator, and we are going to go into stats mode, and we're going to do our distribution, normal distribution, and we want to do the inverse normal. So for this, the tail that we've shaded in the tail on the left hand side, so that's good. The area is 0.15, so 15%, and we've got a standard deviation of 1 and a mean of 0. So that is going to give us there a Z value of negative 1.036. So I'm going to write that on here. So that's going to give me this Z value there of negative 1.036. Okay, so now I'm going to use all of that information and my formula to work out the mean. So Z is equal to X minus the mean over my standard deviation. So in this case, my Z value is negative 1.036. My X value is 7. I don't know what the mean is yet, and my standard deviation is half an hour. So I want to rearrange this formula. So let's get rid of the division, and the opposite of dividing by a half is multiplying. So we're going to go negative 1.036 times 0.5 is equal to 7 minus the mean. Simplify that together, and that gives me negative 0.518 is equal to 7 minus the mean. And what I'm going to do now is take my mean over and also move the number over at the same time. So I'm going to get the mean equals 7 plus 0.518. So that minus mean got moved across and became positive, and this minus 0.518 moved over and became positive. So that's going to give me a mean of 7.518 hours. Okay. Now let's try a little bit more, one's a little bit more tricky. The number of hours of sleep they get is normally distributed, and it's got a mean of 8 hours. So we're going to put our mean of 8 hours there. We want to find the standard deviation, so that's what we're going to calculate. And we're told the probability that a student gets between 6 and 8 hours. So I'm going to draw a line here for 6, and I'm going to colour in this area between 6 and 8, and that area is 0.39. Okay, now if we think about our calculator for a moment, if I just go back to this screen, when we do the tail, we've got the option of left, right, or centre. So a left-hand tail would be a distribution where we've shaded in the left. A right-hand tail would be one where I've shaded in the right-hand side. And a central one would be, say, if I wanted the middle 50% of my data. So what we have in our diagram doesn't look like any of those three. So we need to do a little bit of manipulating first. And so to do that, I'm just going to switch colours here. We are going to find how big this area here is. So this little orange piece there. So I know that from the mean down, that's 50% of my data. So if I do 0.5 minus 0.39, that tells me that my little shaded area is going to be 0.11. So now when I come to do my calculator, that's the left-hand tail probability that I'm going to use. So let me switch back my pen. So let's go to our graphics calculator, and we are going to use our tail here. It's a left-hand tail, and it's a tail of 0.11 with our mean of 0 and a standard deviation of 1, and that gives us our negative z value of negative 1.2265. So that's the equivalent value that I've found on my z distribution is negative 1.2265. So on that z distribution, we found that area of 0.11, we found that z value there. Okay, so now we need to do some rearranging to find the standard deviation. So we're going to take our z value, and we're going to take our value of 6, because that's where the z value is, that's equivalent to it. And we're going to take our mean of 8, and we're going to substitute those into our equation. So that will give me, so z equals x minus the mean over the standard deviation. So z is negative 1.2265 is equal to, now my x value was 6 hours minus the mean of 8 hours. Oops, I can write that as 8 over my standard deviation, which I don't yet know. Now I want to rearrange, and I don't like having divided by the standard deviation on the bottom, so let's multiply that across. So what negative 1.2265 times my standard deviation equals, and 6 take away 8 is negative 2. Now I want to get the standard deviation by itself, so the opposite of multiplying by negative 1.22 is dividing. So I'm going to get my standard deviation equals negative 2 divided by negative 1.2265, and that's going to give me a standard deviation there of 1.63 hours. So there is how we find our standard deviation. Let's try a third example. So the number of hours of sleep a student gets each night is normally distributed with a mean of 8 hours. Okay, so I'm going to put my mean there of 8 hours. Don't know the standard deviation. And I want to find the standard deviation if the upper quartile is 8.5 hours. So let me go back to box and whisker graphs. When we talked about upper quartile, our lower quartile is down there, and our upper quartile was there, and it's quartile, so we split the data into quarters. Yep. So each section was 25%. So in this case, above the upper quartile is 25% of our data. So I'm going to draw a line here at 8.5, and that area that I'm shading above it is 25%. So now I want to go and find my z value. So let's jump into here. Now the area that I've shaded in is on the right hand side. So I'm going to go and change my tail to right. The area, it's 0.25 because it's the upper quartile. And my standard deviation is 1 and my mean is 0. That gives me my z-score there of 0.6745. So that's going to give me z equals negative 0.6745, sorry. 6745. Okay, now I need to rearrange and solve. So let's try that. So z is equal to x minus the mean over my standard deviation. So in this case, negative 0.6745 is equal to my x value was 8.5 hours minus the mean of 8 divided by my standard deviation. So let's get rid of that divided by standard deviation. Negative 0.6745 times the standard deviation equals, now 8.5 minus 8 is 0.5. Now let's divide through to get the standard deviation on its own. So 0.5 divided by negative 0.6745, and that shouldn't be a negative. I've made a mistake when I did this one here on my calculator. What have I done? Oh, it is positive. I've just written it down as negative. Sorry guys, cross that negative out, and I'm just going to cross this negative out here too. Okay, so then when I work out my standard deviation, it'll be better because I can't have a negative standard deviation. That's going to give me a value of 0.74 hours. Okay, so that's our standard deviation. Now one more, and this is a nastier example. So what we've got here is we actually need to find the mean and the standard deviation. So we need to do some of what we've been doing now, and we need to use simultaneous equations to work this out. So let's put all the information on our diagram first. We know the number of hours of sleep is normally distributed. Only 1% get less than 5 hours. So I've got some point down here where the area below it is 1%, and only 1% get less than 5 hours. Then 5% get more than 10 hours. So pick a value there, there's my 10 hours, and 5% get more than 10 hours. So let's think about what we can do. Well, we know there's an equivalent Z distribution. And for that equivalent Z distribution, I know the mean is 0, standard deviation is 1. I can find a Z value so that the area below it is 1%, which is 0.01. I can also find another Z value where the area above it is 0.05 or 5%. So I'm going to call those Z1 and Z2. And I need to find both of those Z values. And then I've got to do some more calculations with it after that. So let's find the Z values first. So the first one, I'm going to do the tail on the left hand side. So change that to the left, and that's an area of 0.01, so only 1% are in the tail. So that's going to give me a Z value there. So that's my first value, Z1, of negative 2.3263. So I'm going to get Z1 equals negative 2.3263. Now I'm going to find my Z2 value. So now I'm going to do the right hand tail, and that has a probability of 0.05 or 5%, and that gives me a Z value there of 1.6445. So Z2 is 1.6445. Okay, so now I'm going to take each of those. Now that first value of negative 2.32, that Z value is equivalent to this value of X value of 5. And the negative 1.6445, that's equivalent to the Z value of 10. So I need to make sure that I'm using them in the right calculations. So we're going to say Z1, X minus the mean over the standard deviation, and X1 was negative 2.3263. So that's equivalent to the X value of 5. Take away the mean over the standard deviation. Notice our problem? We've got a formula with both the mean and standard deviation we don't know. So let's keep going. Let's write down a formula for Z2. X minus the mean over the standard deviation. So our Z2 value was 1.6449, and that was equivalent to an X value of 10 minus the mean over the standard deviation. So what I have now is I've got two formulas with two unknown variables. And so what I need to do is solve these simultaneously. So I'm going to first do a bit of rearranging to either get the standard deviation equals or the mean equals to make it easier for me to do the solving. So I'm going to, the equation on the left, I'm going to get negative 2.3263 times the standard deviation equals 5, take away the mean. Then I'm going to get the standard deviation by itself, 5 minus the mean over negative 2.3263. I'm going to do that same process with the second formula. 1.6449 times the standard deviation is 10 minus the mean. So the standard deviation is 10 minus the mean over 1.6449. Now both of these values that we've got, if I go back to our previous slide, both of these values are from the same distribution. They have the same mean and the same standard deviation. That's what simultaneous means. So what we're doing is we're finding the mean and the standard deviation that is the same for both of these values. So in terms of my equation, what I can say now is that this equation here is equal to the standard deviation. This equation here is also equal to the standard deviation. Therefore, both of those equations must be equal to each other. So this is now what I need to rearrange and solve. So this might take us a second or two, but that's all right. We will get there. All right, so new slide here. So I'm going to take those two formulas, 5 minus the mean over negative 2.3263. That is equal to 10 minus the mean over 1.6449. So fraction equals fraction. Let's see if we remember our rules for algebra for rearranging this. So when we've got a fraction equals a fraction, we can cross multiply. So the bottom on one side times the top on the other, and vice versa. So I'm going to get 1.6449 times 5 minus the mean is equal to negative 2.3263 times 10 minus the mean. Expanding brackets, what do we remember about that? So now I'm going to do 1.6449 times 5, and that is going to give me, let me find my working, 8.2245, and then I do the 1 point that times the mean, and that's going to give me minus 1.6449 times the mean. Now let's expand this other side. So we're going to do negative 2.3263 times 10 and then times the mean. So that's going to give me negative 23.263 minus, and minus times minus makes a plus, so it's going to become plus 2.3263 times the mean. Okay, so now I need to collect all the means on the left hand side and all the numbers on the right hand side. So negative 1.6449 times the mean, take away 2.3263 times the mean, is equal to negative 23.263 minus 8.2245. Now I can collect the like terms together. So negative 1.6449 times the mean minus 2.3263 times the mean, that combines together to give me negative 4.2553 times the mean. And combining the right hand side gives me negative 31.4875. Nearly there. Now I just need to get the mean by itself. So I'm going to get the mean equals negative 31.4875 divided by negative 4.2553, and that will give me a mean of 7.40 to 2 decimal places. So I've just found the mean. Now remember, I needed to find the mean and the standard deviation. So now we need to think, well, how do we find the standard deviation? Well, if I go back to this previous slide, we had two formulae that equal the standard deviation. So I just need to choose one of those and substitute that mean back into this formula, and that will give me the standard deviation. So that's what I'm going to do here. So I'm going to take the second formula and say, right, standard deviation equals 10 minus the mean I've just found, which is 7.40. Divide that by 1.6449. And I know the numbers are horrible, but that's okay. And that's going to give us a standard deviation of 1.53 to 2 decimal places. And that is how we do simultaneous equations, finding the mean and the standard deviation. And yes, this is a very nasty example, but this should be as bad as it gets. Okay, so your turn now to have a try of those other exercise questions.